So today what we're going to do is we're going to learn how to look at a probability situation and create a tree diagram that represents it. So let's just take a minute to read this. Tennis great Roger Federer made 63% of his first serves in the 2011 season. When Federer made his first serves, he won 78% of his points. So something to notice when you look at these kind of questions. This first sentence is sort of an overall probability of how often he'll make the first serve. And then when you read the sentence, what you notice is it's sort of like a subset of the first sentence. It says when he made his first serve, he won 78% of the points. Then next it says when he missed his first serve, he had to serve again and won only 57% of the points. So the blue highlighted sentence and the purple highlighted sentence are sort of subsets of that yellow sentence. So here's how we're going to start our tree diagram. What we're first going to do is represent this yellow sentence in a sense. What we'll say is, right, he either makes the first serve or he misses the first serve. And in statistics, you can write this little C here. So C means complement. Complement basically means not the first serve, right? So he makes the first serve 63% of the time. They mention that right here in this yellow sentence. And what you'll notice is they don't tell us how often he misses the first serve, but they don't need to because you know that's the other, subtract correctly today, 37%. So continuing, here's what we can say next. I'm going to look at the blue highlighted sentence. That's telling me that if he made the first serve, he won 78% of the points. I'm going to write W here for win, and that happens 78% of the time, or 0.78. And then this branch would be W complement, which basically means he didn't win. Again, you have to subtract on your own. 1 minus 0.78 is 0.22. Okay, so then finally, we're going to look at that purple sentence, and that's saying if he misses the first serve, which happens 37% of the time, in that case, he only won 57% of the points. So he misses the first serve complement, and he wins 0.57 of the time, or 57% of the time. And then he doesn't win, we say win complement, 1 minus 0.57, which is 0.43. So the whole point of making the tree diagram is that we can now answer interesting questions. So obviously this person cares about winning, so a fair question might be, what's the probability that this person wins? And when you look at the tree diagram, what you realize is that there's sort of two pathways for winning. Let's use the highlighter again here. I didn't use the color green. So let's use that. You can see there's a way to win along this path where Roger makes the first serve and then goes on to win. Or Roger can miss the first serve but still go on to win. So you'll notice these two pathways represent the two possible ways this person can win this match. So how do we find the overall probability? Well, you consider them case by case. So this first case up here, it is 0.63, because 63% of the time he makes the first serve. And then out of those 63% of first serves made, 78% of those times he went on to win the point. And then the second branch, the second way that he could win the match, or point that is during the 37% of times where he misses the first serve, but then in 57% of those 37% of times, he goes on to win anyway. So we just have to multiply these two things together and add them up. If you do that, you will get that the probability of winning is getting 0.7053, or about 71% of the time this person will win. Oops, I just realized I read my calculator wrong. So this should have been 0.7023, which is really about 70%. Sorry about that. Okay. We can go on. We can actually ask another interesting question here. So that's what I'd like to do. We can bring conditional probability back into questions like this. The tree diagrams really help us in this setting. Sometimes these questions fall under a category called Bayes' theorem. We're not required to know that term for statistics, but here's a question we could ask. We could say, what's the probability that he won the first serve, given that we know he won the point? So we can answer the question. So think about it, right? There's two ways to win the point. We already discussed that. So that becomes the denominator of our probability. Because there's about a 70% chance that he's going to win the point, regardless if he wins the first serve or not. So then the numerator becomes the probability of just winning the first serve. We can do that by looking at just that top branch there. So it's 0.63 times 0.78. Looking here and here. So put that on the top, 0.63 times 0.78. And this becomes the probability that you won the first serve, given we know you won the point. It's a sense of how important winning that first serve really is. Let's take a minute to calculate. So this ends up being about 0.6967, or basically about 70% of the time. Okay.